1-7 part 2 takeaway, the distance formula. The distance formula, there it is. It's basically where you're going to subtract the x's, square them. You're going to subtract the y's, square them, add them together, and square root them. Kind of a lot going on there. You can just use the formula, plug in numbers, chug it out. It will give you the distance. I tend to not like to do it that way. It doesn't really teach you what's going on. And it can get a little complicated, and there's a bunch of rooms for error there. So I like to teach it using the Pythagorean theorem, which you guys have learned before in pre-algebra, should have. So Pythagorean theorem, a squared plus b squared equals c squared. What the Pythagorean theorem does is it takes a vertical distance, a horizontal distance, and it helps you find a diagonal distance, which is what we're trying to do here. When you get these 2 points, it's on a coordinate plane, like point A and point B. What you're trying to do is you're trying to find the distance between these points, and when it's on a diagonal like that, it's sometimes hard. You can't just count the units like you normally would. It's a little bit more difficult, right? You're going to a lot of times get decimals and stuff, okay? But there is a way to do it. Again, you can use the formula, just plug in your x's, plug in your y's, and chug it out. That's fine. But I find that the Pythagorean theorem is a little more familiar and just a little less intimidating. So what we're doing is we're doing the horizontal distance, the vertical distance, and that will help us find the diagonal distance there. And that highlighted yellow distance is the distance that we're looking for, the distance between point A and point B. Okay, so the horizontal distance. How far away horizontally is this point and where this point would be if it was down here? Basically the question is, how far away is the x coordinates? How far away is -7 to 4? How far away are they? Yes, Michael. 11 units, yeah. You can kind of think of that in your head, right? Count them in your head maybe. It's really just a subtraction problem, which is where it gets that from the distance formula. It's just subtracting it. A -7 minus 4 would be a -11. When we're dealing with distance, we don't deal with negatives. We just deal with a absolute value, a distance from 0. So -11 would be 11 units from 0. So that horizontal distance is 11. The vertical distance, 5 and -3. How far apart is 5 from -3? 8. Again, you can count them, you can think of it in your head, but it's really just a subtraction problem. To be honest, the way I do it, I think of it as distance from 0. So 5 is 5 units away from 0. -3 is 3 units away from 0. 5 and 3 give me 8. So the horizontal is 11. The vertical is 8. That's going to help us find the diagonal. The Pythagorean theorem, a squared plus b squared equals c squared. It actually doesn't matter which way, which one you put first. Okay, you'll just you'll get into a groove. You'll probably put the x's first, just because they're first in the coordinate plane. So we have 8 squared plus 11 squared equals c squared. So you take those distances and we're going to square them, just like we do in the Pythagorean theorem. Again, that square comes from there, which again comes from Pythagorean theorem. 8 squared is just 8 times 8, which is 64. 11 squared, 11 times 11, which is 121. That will give us c squared. Make sure you bring that squared down with c, because here's a common mistake. A lot of people look at this and be like, okay, so this distance must be 185 units. That should right off the bat not make a lot of sense to you, right? So, I mean, if that's 8 and that's 11, how is that going to be 185? Well, it's not. We have to square root 185. That is the operational inverse there. What I mean is, to get rid of this square and just be left with a c, we have to square root this number. And that's normally something we're going to have to do on a calculator, unless that's a perfect square. So on your cell phones or in your calculator or on your computer, find that square root button. On an iPhone, I'm not sure about anything else, but on an iPhone, you do have to turn it horizontally here. And then the button, there's a little check mark underneath, over top of an X. So I would do 185, and then I would hit that button, the square root button. And you should get a long decimal. It's what we call an irrational number.
I got 13.6.
185?
Is that button?
No, it's this one right here. Yep.
I got it.
So 185, the square root of 185 is 13.60. We'll go to the 2 decimal places, so 13.6. And that's an approximation, meaning it's not the exact answer. Since it's an irrational number, the exact answer would have to be written as a radical. But the radical number doesn't make a lot of sense to us. Like if I told you to walk or drive the square root of 185 miles, you'd look at me like I'm crazy, right? But if I told you to drive 13.6 miles, you'd be like, okay, I can do that. All right, so again, we are using distance horizontally, distance vertically to help us find distance diagonally. Formula we are using is Pythagorean theorem, which the Pythagorean theorem, as you can see, is relative to the distance formula. They go hand in hand. So we use the Pythagorean theorem to find that diagonal. All right, so our homework then, which we'll do some in class, as much as we can in class, page 62, 1 to 17 all. Go ahead and get a blank sheet of paper out and write that down and put your name on it. I like to teach it as the Pythagorean theorem. I just find it makes a lot more sense to me, and I tend to think it makes a lot more sense to you. So that is, I'm going to rewrite them here, 4 and 5. So the distance between the point 4, 5 and 2, 9. To do this, we're going to find the distance horizontally, find the distance vertically, and that's going to help us, along with the Pythagorean theorem, that's going to help us find the distance diagonally, which is what we want. All right. Question, what's the distance between 4 and 2? 2 units, right? So that's going to be 2 squared. Again, I get the 2 from, this is just like a subtraction problem, but it's, the question is, what's the distance between these two numbers? The distance would be 2. Distance between 5 and 9? 4. So I'm going to put them in the Pythagorean theorem, square them, add them together, and then square root it. Okay, don't stop there. It's a common mistake. Some people be like, okay, the answer is 20. Next. That's not the case. We have to square root it. So find that square root button. It should be between 4 and 5. Here's how I know that. 20 is between the perfect squares 16 and 25. 16 is a perfect square. That would be, the square root of 16 would be 4. 25 is a perfect square. The square root of 25 would be 5. So 20 is between 16 and 25. So that must mean the square root of it is between 4 and 5. What is it? 4.47? What you got? Okay, 4.47. Looks good to me. Yeah, we'll go 2 decimal places. Number 2, find the distance between -1, 7, and 6, -5. To find the distance between these 2 points, we're going to find the distance horizontally, find the distance vertically and use the Pythagorean theorem to find the distance diagonally. That's what the distance formula does. Distance between -1 and 6. 7. Distance between 7 and -5.
12. Wait.
You guys agree? 12? Okay. Yeah, again, in my head, here's how I do that. 7 is 7 units away from 0. -5 is 5 units away from 0. Right? When I add them together, it's 12. So make sure you square them. That's another common mistake. They might just put it down there, and 7 plus 12 is 19. So you must be 19. Nope, that's not how you do it. Okay, you got to use Pythagorean theorem. 7 squared is 49. 12 squared is 144. Add them together. Square root them. Make sure you guys can find that square root button. Alexis? 13.89. Do you guys agree? Let's see if I agree. Yep. 13.89. And again, that's an approximation, but that's going to make more sense to us than square root of 193. All right, another one. I'll write it down. See if you guys can get a head start. Distance between -9 and -6. Distance between 8 and 0. Plugged into Pythagorean theorem. We'll find that distance diagonally. All right, I'll jump in for those who aren't sure. The distance between -9 and -6. -9 and -6. They are 3 units apart. Distance between 8 and 0. Hopefully that's obvious. That's 8. So make sure you square those distances, and then we'll add them together. And my distance diagonally is not 73. My distance diagonally is the square root of 73, which is, class, 8.54. Well done. Well done. Okay, number 4 and 5, I'm not going to write these down. Make sure we're listening to the explanation. How does the distance formula ensure distance between two points are positive? How does it ensure that they're positive? Yeah, good. When dealing with distance, we use absolute value. That's probably, that's what I would put down. I mentioned that a lot when we're dealing with distance. We're dealing with the absolute value. If I was to look up the answer key in the book, it's probably going to mention the fact that they square them. Whenever you square something, that gets rid of the -2. Okay. But again, their focus is on plugging it into the distance formula. My focus is more on using the Pythagorean theorem. So my focus in the book's focus is a little different. Any repeats on number 4? You know how to answer that one? All right, number 5. Your friend calculates the distance. The point is 1, 5 and 3, 8. So in the distance formula, they subtracted 1 minus 8 and 5 minus 3. You guys see a problem with that? So the point is 1, 5, and 3, 8.
Oh. Wait. Oh, no, now you're not right.
When you subtract, what are you supposed to subtract? The x's and the y's. Good. Did they do that? No, they mixed them up, which is kind of it's common really to mix them up. So your friend subtracted the xy's, the x from the y's, rather than the x's from each other. So again, your friend subtracted 1 minus 8. 1 is an x, 8 is a y. You don't want to subtract your x's from your y's. That would be incorrect. Okay, I'm going to get the next page set up. There it is. These next four turn out quite nicely. I'll show you why. The setup is the same. So I'm looking at these 2 points, 2, -1, 2, 5. If it helps you to write one right underneath the other one, I think that does help. Do that. If you need to write 2 and then -1 and then right below it 2, 5, I think it helps you line up the x's and y's. Anyway, the distance for the x's, the distance horizontally. What's the distance between 2 and 2? 0. Well, that's nice. 0 is magical. It's going to make things disappear. Distance between -1 and 5? 6. So you set that up into the Pythagorean theorem. Again, that 0 disappears. It's not going to change the value of anything, so I just bring down the 6 squared, which is 36. And square root it, and I get 6, c equals 6. You guys catching on?
Yeah.
Number 7, same idea. When you're dealing with zeros, it makes it a lot easier. I want to point out one thing on here on number 17. So distance between 10 and -8 is 18. Distance between 14 and 14 is 0. 0 makes things disappear. I don't need to square root that. I don't need to square root 18. I'll show you why. When you're dealing with zeros, that disappears. If I was to square it and then square root it, that would be like adding 10 and subtracting 10. You're not going to change the number, okay? They are operational inverses of each other. So from here, I would just, maybe show the work. I square root both sides, but that square root and square cancel, and I'm just left with c equals. You guys follow me? What would c equal then? 18, yeah. So that's going to work for the next 2, yeah. But then 10 is where you're not going to be dealing with zeros anymore. Why don't you guys do those on your own? And if we have time, I'll jump back in on number 13. All right, I will adjust this picture here. It's the same idea. The only difference is we're going to need to find these coordinate points. So let's find them. It's Augusta. Looks like it's at 0, 0. That's nice. So write that down. And Brookline, which looks like it is at, those go by 2, so that's 8, 2. What I want to do, guys, I want to go ahead and write these down. and then you can go back and do distance, okay? So Brookline, well, we already know what Brookline is, don't we? It's at 8-2, it ain't gonna move. Charleston, 4 and 5, 4-5. $15. Another Brookline. We ain't gonna move that. It's still the same thing. Davenport. In between there, so it's 5 and 10. 5, 10. $16. Everett and Fairfield. Everett looks like -3, 5. Fairfield, -8, -3. $17. Last one. List the cities in order of least to greatest distance from Augusta. All right, so we have all the coordinates from Augusta, so that's from the origin. I'm almost out of room. I'm probably going to need another page here for this. All right, go ahead and do 13 through 16. And I'll get 17 set up here. All right, I'm going to jump in here real quick. So it's Augusta to all these other cities. So I tried to just kind of go in order what looks closest. So Augustus to Charleston, Augustus to Everett, Augustus to Brookline, which we already know. We did on number 13. So on and so forth. So we're going to need to find the distance, but maybe we don't have to do all the work. So let's see. If I have 4 or 5 here, that's going to be 16 plus 25, right?
Yeah.
Okay. Down here, the 5s are the same. That makes that easy. But that's going to be a 9, right? When you square it. So which one's closer? Would it be this one, which is Charleston? Would Charleston be closer or Everett? Closer meaning the shorter distance. Which is going to have the shorter distance? Charleston or Everett? Here's what I'm looking at, guys. Smaller distance, smaller number, right? Well, the 5s are the same. The 4 and the -3 is where it gets different, okay? But 4 is bigger than -3, absolute value-wise, okay? So that distance is going to be a little bit bigger than that distance. So ordering it, we would first start with Charleston. I'm just going to put C because I'm out of room. I'm sorry. The first one would be Everett. What did we get for Brookline? Before we get too far, what did we get for 13? 5? 8.24. Okay. I would say the next one would be what? I mean, Everett and Charleston were so close. Next one's Charleston. Looking at the map, what would be third closest? We did Everett, we did Charleston. The third closest, would it be Davenport, Brooklyn, or Fairfield? I would say Brookline. Okay, the last two, they're down here. That's Davenport, that's Fairfield. But again, so that's going to be 25 plus 100. When I square them, that's 125. That's going to be 64 plus 9. Which one's got the shorter distance? That bottom one, right? Which is Fairfield. And then the one that's farthest away would be Davenport. So listed shortest to greatest, right? Yep. Least to greatest distance, least to greatest distance. I just used their first letter there to identify them. Are we finished? Okay. If you're listening from home, if you want to just take a picture of that, your assignment, and send it to me, that would be fine. Otherwise, you can turn it in when you see me next.